I'm Tad Masek. I'm going to speak about being an autonomous systems operations engineer at MBARI. And title really rolls off the tongue. I always have a hard time saying it. It's not even a good acronym, but here we go. So I work at MBARI, and we're out in Monterey, California. And if you've heard of the Monterey Bay Aquarium, it was founded by Julie Packard, David Packard's daughter, while her and her friends were at Hopkins Marine Station, which is the Stanford's um, uh, marine lab down in Monterey, and there wasn't a really good aquarium on the West Coast. So they got funding together and built the Monterey Bay Aquarium out of one of the old canneries. David Packard is the Packard part of the HP of Hewlett Packard. So that's where all the funding for the aquarium and the research institute come from. And while he was working on helping build the aquarium, he was realizing that a lot of the research institutes were the scientists made all the calls, they would hire the engineers to do the research. And he wanted to come up with a new research institute where all three of the groups were actually equal. So we have scientists, the engineers who make the things, and then the marine ops who actually deploy it and everything like that. And all are on equal footing. So you'll see all three of the groups writing papers. And when we go to meetings, we all pulling equal weight and everything like that. So it's a really neat, unique place to work at. It was founded in 1987, so we are definitely one of the young groups compared to the Scripps or the Woods Hole out here. So we're located here in actually MBARI is located here in Moss Landing, which is the midpoint of the Monterey Bay there. And what's really cool about this location is you see we have the Monterey Canyon that leads right up to there. So we have really easy access to very deep water. The canyon goes down to 4,000 meters. The canyon walls could be up to 1,500 meters. And after we've done a bunch of research there, it turns out that canyon is very dynamic geologically. Back in the early days, they were putting sensors out to measure things, and they were getting washed down the canyon or getting buried in the mud, and they were having to recover them using the ROVs and everything like that. It's also an exciting place because when the gray whales migrate, it's where the orcas hang out and will actually ambush them coming across the canyon. We also get upwelling and everything like that pulls these really deep water animals and nutrients up. And so that's what gives Monterey Bay a lot of its life and exciting diving. And so if you're into scuba diving, it's definitely a great place. And if you look just south of the little peninsula there, part of the oh, I moved it. Part of the canyon comes all the way up to where you can actually surface swim to do a couple 100-foot dives. How did I? Oh, is it not centered? That's weird. All right. So I work in the group of the marine operations. So we have the scientists who do the scientific research. We have the engineers who build the sensors, and the marine ops, we are the ones who take all that equipment out to sea and deploy it. The group I'm part of in marine ops, so marine ops comprises of, our research vessels, diving, and I work for the autonomous system vehicles. We're a team of 7 people, 7 engineers. We have 2 software, 2 electrical, and 3 mechanical. And then the vehicles we have are liquid robotics wave gliders, Tethys class long-range AUVs, which were actually developed at MBARI, and the Dorado class AUVs that were developed at MBARI. Fun collage of all the different work. So what I really love about this job is it's 3 parts equal being out at sea, deploying things, being back, maintaining the vehicles, working on them. And then a third of my time is actually writing code and making circuit boards. So it's, I quickly get, as we've heard from everybody else, like doing just the one thing every day would just get boring way too fast. So this is great. And then you have your day planned out, and then one of the vehicles will get caught in a crab trap and you have to do an emergency boat trip out to recover it. So nothing, it's hard to plan, but it's very interesting all the time. This was actually from a expedition last in August in Pacific Northwest, we're having to do mapping there off of the Oregon coast. And so this is a harsh marine ops of deploying an AUV. But this is a perfect example of one of the things with this job is making tough calls. So in this case, these are very hard conditions to be deploying this large of an AUV in. But it costs a lot of money to get out there. It's a lot of time and effort. We knew the weather was going to get better the next day. This was an 18-hour mission, so we felt comfortable deploying the vehicle this day, knowing that the next day we'd be able to recover it. So there's a lot of choices and things to be made. All right. So our wave gliders, these are actually an off-the-shelf solution. Originally started with made out of a surfboard, but it's a really cool design in that you have the float up top, this rubber umbilical to fins down below. And as the vehicle rides up on a swell, the fins actually propel it forward. So it doesn't take any energy to propel it. So unfortunately, on a very calm day like this, it's not going to move very well. But when there's a nice swell coming through, you could actually, it's just going to drive it indefinitely. The solar panels and the batteries on board are for the scientific equipment. Just some of the specs. The endurance is 1 year. That really depends. Actually, our endurance is not more than a month just due to all the biofouling we experience in Monterey Bay. So after a month-long expedition, it'll come up with the barnacles being 3 to 4 inches long on it and just really destroying the drag. So that's our big limit. The kind of science we do with this is bioacoustic imaging. So there's a really high-end fish finder on this, and we have scientists who are trying to do surveys to actually figure out what's the bioacoustic fingerprint of the different animals are. We have a CO2 sensor for measuring the CO2 of the ocean in real time and sending that data back. That was developed at MBARI. A couple CTDs, turbidity, and then this will also work as an acoustic relay for AUVs. So we could have the AUVs underneath doing acoustic modems up to this, and then this will either send an iridium message to the satellites or a cell message if it's close enough to shore back, and we could find out what our AUVs are doing. Another one of our AUVs that we developed in-house is the long-range AUV. And the things that make this a really cool design are, if you look at the cutaways there on the right side, the battery pack's movable, and then to adjust the trim, and then there's a buoyancy compensator in there. So what this lets you do is actually trim the vehicle perfectly in the water column, which is actually one of your biggest drags when you deploy vehicles. And so this has a really good endurance. There's 2 different sizes. There's the short nose and then the long nose with the ESP. And we'll talk about the ESP in just a second. So the different science this vehicle is using is eDNA through ESP, high bandwidth acoustic modems, a planktivore, MBTS, water samples, piscivore, docking, and CTD. And I guess we haven't covered CTD is continuity, temperature, and depth. It's kind of like your quintessential scientific measurement when you're doing research. So here's ESP. I'm actually going to let the little video they have talk about it because it's going to do a better job than I can. It's only
environmental DNA or eDNA.
So yeah, so that's a really fun, interesting project. And actually what they don't really tell you is most of it's just poop. So it's whale poop, fish poop, that's all your um, environmental DNA in the water column. Another one of our AUVs is the planktivore. And so these two big tongs going out the front, there's actually a really powerful microscope. So this measures the plankton as the AUV is going through the water. And the scientists are able to bring that back. At MBARI, we have a huge video library. Everything gets annotated and then stored and accessed by other researchers. So the last one we're going to talk about is really fun. This is the piscivore. And what the problem this is trying to look at is it's really hard to do surveys on marine predators. They're usually isolated, they're usually hiding, doing their own thing. So what this has is a forward and backward looking camera and actually just runs a fishing lure and does transects throughout the bay to see what we see. And then so here's a quick video of some of the cool things that the piscivores have seen. So the other AUV we have is the Dorado AUV. This is our deep water AUV. It was actually developed in MBARI, started in the late 90s. And so most of my job right now is actually trying to upgrade this to newer technology because the software on there and a lot of the components on the motherboard are no longer available. And so that's actually a really interesting project that I've done a lot now is taking these things that have been developed 20 years ago and trying to upgrade them now to the newer technology. This vehicle is rated to 6,000 meters. And has an endurance of around 20 hours. It's quite modular. And so the length, we have four of them. They go between 2.4 meters and 6.4 meters. These two are the Gulper and the I2 map. And the way we get the 6,000 meters is actually really cool. Instead of having a pressure hull, we have everything's housed in these glass spheres. And then so the actual body of this is just a frame to keep all these glass spheres together. And that allows us to get the pressures. So out of these, one of them is called the I2 map. This has a forward-looking camera and then that bioacoustic imaging sonar. And what this does is does transects out in the Monterey Bay here. It does one at the afternoon and one at midnight. And then they compare the what they've been seeing. And so here's like a breakdown of all the different animals they've been seeing and how it varies between day and night at the different depths. The oldest one we have is the Gulper. And this actually is part of the Monterey Bay time series. And this has been running the same mission for since 2007 in Monterey Bay, collecting 20 water samples. So we've been getting a long-term time series. And so we built these Gulper bottles and it sits there. And if you look at the picture on the top right there, real closely, you can see down below is the 20 holes that the Gulpers pull the water samples out of. Also, while it's doing this, it collects CTD, nitrates, optical backscatter. The CTD is really important for actually quantifying the water bottles and everything and where it is. And then here's some of the data from that time series. I think they're pretty graphs. I can't explain to you what they do. I do circuit boards. And then last we have the mappers. And what's another neat thing about this design of the Dorado is if you have worked with any towfish or anything like that, our all our staves and everything are actually inside. The housing itself is acoustically transparent, so we're able to reduce drag and make it more efficient. On the right there, you can see the different types of sonars imaging this is doing. This has the top one there is a side scan sonar. The second one there is the microbathymetry. So that's a high frequency downward looking sonar. So with underwater sonars, your frequency is directly proportional to the lower the frequency, the higher the range, but the lower the resolution. And so that's where these AUVs have really changed this technology, is these AUVs could get a lot lower to the grounds with a higher frequency sonars to get better resolution. And then the bottom one is actually a sub-bottom profiler. So that will send a low frequency sound wave and have it reflect off the different substrates. And so you could actually, a geologist could, I cannot, tell you what the difference, what's going on underneath the sand there. Here's another quick video of one of the PIs who actually is using this technology then to do really high resolution maps. So that's a good video on like reaching back to what Mark said, that none of this is done in a vacuum. This is a lot of work done with the, you have your geologists, you have your engineers, you have your boat operations people, and we all have to work together as a team to do this research together. Thought to do a quick slide of what next week's going to look like for me, except it's probably going to change the minute I get back. But right now I'm scheduled for doing 2 days at sea, deploying the I2 map. And that's always a fun one for me because from a 10-hour boat day, my work is only 45 minutes. And then I get to sit and watch the scientists collect samples with the ROV. And so I sit and have lunch and then watch that. Then I get back. I have 3 different software projects I'm working on. Right now I'm trying to clean up some data from the Wave Glider. Another one is you get off the shelf solutions and they work great, but they only covered 90% of what we needed to do. So trying to write software to integrate, to use their binary data ports and stuff like that. So it's fun to go in and hack and hot rod and stuff like that. And then another problem we have is I'm writing software to actually QC our sonar data as we collect it. Right now, we'll send a vehicle down, and if there's a hiccup down at 4,000 meters after it's taken a couple hours to get down there and run for 18 hours and get back, and we don't have data. So trying to write more software now to QC and make sure we're collecting data so we know to continue the mission or not. And then clean the ROV, clean the AUVs and get them ready for their next mission. So history of how I got here. I was going to be an airline pilot. I loved airplanes. I was actually a flight instructor. And I went up to San Jose State. And while there, I actually took scuba diving for PE. I grew up down surfing and everything like that and fishing and loved the ocean. I was like, oh, I'll learn to scuba dive too. I've always wanted to. And started working at the dive shop. What I also learned was I did not want to be an airline pilot. For me personally, it looks so boring. So I got kind of panicky and figured out, I don't know what I'm going to do. So I actually dropped out of school, moved to Monterey to work the dive boats down there. And so while at Monterey, I'm like, oh, I should probably go to college. And Cal State Monterey Bay had just started. It was like 3 years old when I enrolled there in 99, pardon me. And it was a really cool opportunity. Our classes were like 6 people. And this has been hit home by everybody, but do the internships. Luckily, with only 6 people, there wasn't much competition for the internships I was going after. And so it helped me figure out a lot of what I did and didn't want to do. One of my first ones was with a hard hat diving outfit, and I was helping maintain their ROVs. And amazing people loved the job, but realized I did not want to be a hard hat diver. And then I started designing these wind sensors for another researcher, and I got to go snowshoeing through the backcountry of Yellowstone during the off season and deploying these anemometers and collecting the data. And that's where I really realized I liked that bridge between engineering and being in the field. I just didn't want to sit in a lab and work, but I wanted to make stuff to make the science's job better. So after graduating, I got hired at Light Motion because a roommate of mine was working there and they needed a manufacturing engineer. My undergrad was in watershed restoration. I used a lathe once, but took the job. And we were making housings. Turns out I wasn't very good at that, but they found out I was good at programming. So I went over and actually started writing the code for the housings and the lights. While I was doing that, I was still working the dive boat, and the Navy at Naval Postgraduate School is actually hiring us for their AUV work to deploy it and recover it. And I'd have to dive and pick it up when it gets stuck. And so from that job, they actually found out I could tie knots and program. So they hired me. And that was a really amazing opportunity. They actually covered my master's work, and it's in computer vision with robotics. And this is kind of my lesson that get Mark set up. Try not to specialize, because my graduate work, I met with it was in computer vision, and then 3 years later, everything I learned was completely obsolete due to all the groundbreaking things done with AI work. So be careful if you specialize, because especially in technology fields, it can all be shut off within a few years. So diversify. So Oh, if you see the top right picture, that's actually Mike, because I could no longer just work the boats. So we had a new guy swimming after our AUVs, but yeah, I was programming, working on forward-looking sonar algorithms, and just having an amazing time. We also had some underwater glider AUVs, and these are really cool. If you look, they don't actually have propellers. What they use is they have a buoyancy engine, so it makes them negative or positive buoyant, and they have wings. So the only time it uses energy is at the top or the bottom of its flight path, and it'll sit there and glide up. So this gives them a really long range or really long endurance. It also makes them super quiet. So we were doing a lot of acoustic research with them. I got to go up to Pavilion Lake in the middle of Canada and cut holes in ice and deploy our AUVs there. And this was a neat project where actually we took the stuff I was designing, the software I was writing for the AUVs, and actually worked with Special Forces, the SWIT guys. And we did our forward-looking sonar and put them underneath the SOCAR boats. And I took a video game engine and actually superimposed our sonar data over the video game engine, and the drivers were able to drive around and see underwater obstacles from the boat. After that, I actually worked for Hollis, doing some software for the rebreathers, and then a bunch of jobs like for drawing a blank. Sorry, I've ebb and flowing with the coffee hits. But main thing is, yeah, for closing, definitely do the internships. We have a great internship program in MBARI if you want to come out to the West Coast. The other thing is, don't stress over knowing what you want to do. My daughter's graduating high school right now, and my son is a sophomore, and they're really stressing the fact that you need to know what you want to do and what school you want to go to. And I'm telling them, relax, just go down the path that's interesting, but be open to really changing the minute something more interesting comes along, or that you realize it's not what you want. So the best thing to do is start going down a path and then be open to make the choices. I think that was both really fast and really slow. And any questions?